Hello, today I am going to explain briefly about another solid principles which is called open closed principle. As name suggests, this principle states that your architecture or system design should be open for extension but closed for modification. Existing class should not be modified. So, design should be done in such a way that the system architecture is open to create new classes to add new functionalities instead of modifying the existing classes to add new functionalities. Advantages of the open-closed principle. So, it avoids rigorous regression testing, which means that as you are creating new classes for adding new functionalities and existing classes remains untouched, you do not need to test the existing classes again if you add your new functionalities. Less error prone as the existing classes kept untouched, tests confined to new functionalities that are added. So only the new functionalities can be tested. More advantages, separation of concerns. Of course, as you are adding separate classes for separate functionalities, which actually maintains or follows the separation of concerns. Easy to maintain, easy to understand, easy to test, increased reusability. The base class remains clean, and new classes for new functionalities follows single responsibility principle as well. Now I am going to show you a brief sample implementation about open close principle. In this invoice base which is violating OCP, we see that this class contains two methods for different invoice type. For example, proposed invoice and final invoice. So if another invoice type comes in as a requirement, then we have to add another method for that new invoice type. So we are actually modifying the invoice base class, which is violating the open closed principle, where we should not modify the existing class. Now, in order to follow the open closed principle, what we can do, we can create abstract class and method for the abstract class, or in my case I am using interface and defining a method. And for the different invoice types, there are different invoice classes are created. For the final invoice type, there is a class called final invoice, which is actually implementing the interface, and the proposed invoice type, which is also implementing the interface. So if another invoice type comes in as a requirement, we can create another class, let's say new invoice type class, and we'll implement the same interface. So it is actually following the open close principle because we are creating new classes for new functionalities. So we are extending our architecture and we are not actually touching the existing classes, as it maintains the open closed principle. So in the program class, for the invoice base violating OCP class, we are actually calling the method for different invoice types by creating the instance of this invoice violating OCP here, and final invoice, this one. If we need to add another invoice type, we can create another method and call this method from there. And this one, we are following the OCP, where we are initiating proposed invoice with the interface that it has implemented. So the proposed invoice, we have a method, and we are calling the proposed invoice method, and here for the final invoice we are actually assigning the final invoice to our interface and calling the final invoice method. So if another invoice type comes in, we will just assign the new class of new invoice type to the invoice interface and call that method. If we run this application, so we have proposed invoice violating OCP and final invoice violating OCP, and here we have actually proposed invoice and final invoice. In the last two lines, we are following the OCP. I think you have understood the open close principle. So I will try to explain other solid principles also in my next video, where I will discuss about least scope substitution principle.